We are going to look at data analysis. This is another one that's going to build from the white belt through yellow, green, and into brown and black. We're going to start with just ChatGPT here, but we highly recommend creating a GPT or project because you're going to be giving pretty specific instructions to the AI for how to do analysis and pretty specific context to make it an expert in analysis. On the yellow and green belts, we'll go further to look at how we build full workflows of analysis. This will be a little bit of an overkill to use AI just to do some of the analysis we're going to take a look at, but it will give you the patterns to be able to apply as you advance in the belt system. Let's go ahead and go back to our Major League Baseball example. And here's some of the data that we get from the Claritas dashboard. We can see here that we're looking at the ad response by day of week. This is a good dashboard, so it just shows you what the right answer is, but we're going to try to figure out if AI can find it as well. Here you can see that the impressions are being delivered across the week with heavier impressions on Saturday and Sunday. But interestingly, the conversions are highest on Monday, Tuesday, and Wednesday. That's a total conversion count. So to normalize the data, you divide the conversions by the impressions. Claritas's standard is to multiply that by 1,000. Conversions per 1,000 is highest on Monday and Tuesday, drops off through the rest of the week, and by the weekend it's at the lowest point. Yet the impressions are at the highest point. So we can just look at this and know that if we were to make a media adjustment, we would want to change to bid less on the weekends and do more on Monday and Tuesday. But let's see if AI can recover the same analysis. Now there's two different ways that we can do that. With computer vision, we could take a screenshot and just give it this as the data, and it should be able to understand that. And we will try it that way. But the more important one is we're going to work with raw data, CSV data, Excel data. And so Claritas has an option in every dashboard to export to CSV, which we'll do. And that file is available for you to bring into the analysis. Now, after we do this simple analysis, we're going to take a look at more advanced analysis, specifically looking at the diminishing returns curve from the impressions by frequency. And we will be fitting our own curve to this data to see where the diminishing returns kicks in, how the cost per impact changes in terms of ticket sales. That will be the second analysis that we'll do. Let's go back to this first analysis. We could give it a simple prompt, calculate the index, and recommend which days of the week have the highest conversion rate. And we will try that. But we're also going to go back to the prompting guide, which says that we should give the AI context and move it to a smarter area of its brain so it can perform better. The thinking modes in general do better without robust prompting, but robust prompting, especially if you're building a GPT or a project, and adding that into the instructions is a good way to get better results. Let's compare the two results that we get from this prompt versus a more extensive prompt. This is a guideline that we provided in the white belt materials. It provides a meta prompt and it talks about context, role, objective, approach, output, guardrails, and evidence. Guardrails and evidence are a little bit of an overkill for this initial one that we're going to look at, but if you're building full-on workflows, then these become important because it's the way in which the system checks itself, and that will be important in automated workflows. In this case, we're going to focus on context, role, objective. We will come back to using that prompt here in a second window. We've got the context here. Consider this context. We're going to use the Wikipedia bivariate analysis, which is a pretty straightforward, simple analysis that we're looking for. We could go more complicated, and we will later on, but we'll go ahead and paste that context here. We are going to grab that same image from the report. Here we are. Now, while this analysis is thinking, we're going to take the same prompt here, open up a new chat window, and in this case, we are going to use the spreadsheet instead of the image. Now, the spreadsheet basically looks just like this. It's not a very complicated spreadsheet. What we're asking the AI to, in essence, do is to calculate another column here, which would be an index. And we'll go ahead and just do that ourselves so that we can see what that looks like. Okay, so to calculate the index, of course, what we need to do is we need to figure out what the sum is for the impressions, sum of the conversions, calculate the overall conversion rate. Then we can divide the conversion rate here by the overall conversion rate times 100, and we can get an index. We can see the index is 43 for Sunday, and it's highest for Monday and Tuesday. Now let's compare that to what the AI has calculated for us. Just giving it the simple picture with a simple prompt seems to have done fine. We see those same indexes there, so 143 and 144, 43 and 38. So that matches pretty well. And we can then follow up with the question of how much less should we bid on an impression over the weekend compared to Monday and Tuesday. And it can tell you with the calculation that we should be bidding significantly less on weekend impressions compared to weekday impressions. So pretty good analysis. Now, if we use the more extensive role, we are getting the conversions and impressions, and then we're seeing the calculation of the index. Again, similar types of data. Now it's giving the interpretation, and we can do the follow-up question of how much less should we bid on the weekend. But it basically has the same analysis. Coming to the last analysis, we can see that it has written some code, thought about it for about a minute, and you can see the code that it used to pull in the data and analyze it, and how it went about doing that analysis. This can be a useful code to copy if you're trying to build a GPT to make something that's repeatable. It's oftentimes very useful to copy the code and give that as an example of how you want to do the analysis, and that provides guardrails on how it should be performing. And that will come up more when we get into the prompting part about the output and the guardrails, where we're telling it how to do the calculations. So that's a useful tip. And then finally, coming back to the analysis that we saw in each, let's go ahead and see. You see the different weeks. They're not ordered the same way. And we can paste in the last question. But let's go ahead and check the answer. So this is the same, lower on the weekends compared to the weekdays. It's sorting it, in this case, by highest to lowest. And again, this is where it becomes important. If you want to control the analysis exactly how you want it to display, then that might be something you'd go back into your GPT and tell it to always use a certain order. Slight variation between the analysis, but all of them coming up with the same right answer and how much less you should be paying for your impressions on the weekends compared to the weekdays. Okay, we're going to hit pause and give you the data set so that you can repeat this analysis. Again, it's a simple analysis. You'll try it with the spreadsheet. You can try it with the image. You can try it with the long prompt and the short prompt. Then we will come back and we will do that more extensive analysis, which is calculating the diminishing returns with curve fitting using this data set, which we'll download and make available for you as well. We are back for part 2 of the analysis. Now, this one's going to get a little bit more complicated. We're going to start a new chat, but we're going to keep the same idea of a very simple prompt versus the more advanced prompting and look at some of the differences. The analysis we're going to do is the most important analysis in marketing ROI. It's going to look at the spend to impact response function, or in this case specifically, we're looking at frequency, and if we multiply the frequency by the cost of the media, we would get to the spend. Now this is really important because each incremental dollar of spending can be put towards the same media, or could be put towards a different media, to a different message, or to a different use in marketing altogether. If you have mastery of this equation, and if AI can help you get to mastery of this equation, then you have the most powerful analytic that you need to make business decision. In this new chat, we are going to take in the file that we were looking at just a moment ago in the frequency data, and we're going to take a snapshot of that. That snapshot's available for you here. Go ahead and capture that here. What we want to do is just see if we can calculate where that point of diminishing returns is, since we only have so much data here in terms of total impressions to work with. The total impressions from this campaign is about 1 million impressions, so it's a little bit light compared to bigger campaigns. So let's go ahead and take a look at the simple prompt version. We insert the image, and again, we're going to download the data also, so you have that as well. We're going to ask the AI to perform an analysis to find the point of diminishing returns. So here's a prompt we've written. In the second prompt, we're going to go back to our more extensive prompt, which has context, role, objective as a minimum, and ideally, as you build GPTs, you would also have ways of doing guardrails and evaluations. The context I'm going to pull for this one is going to be, again, from Wikipedia. I'll use the diminishing returns paper. We'll see how that works. And again, we'll give it the same image. And then the third one, we're going to give it the same prompt, but we're also going to give it the data file instead of just an image. We are back. It took a little bit of time to run the analysis, and you'll probably find that the thinking mode will take a few minutes. This first one we can see took 5 minutes and 13 seconds. This was a simple prompt. We can see the steps that went through, and the key things that we're going to look at is we're going to look at the answer for where it thinks the frequency really begins to drop off. We'll ask it for the equation. We can place that into our analysis. So I asked it to plot the curve and provide the fit equation. It performed the analysis, which I'll shut here. And then we can see its equation. We can compare it to the more advanced formula, and we can check for what the error was versus the actual data. And we'll ask, where should we cap frequency? Okay, so let's go to the more advanced model. Now this one again used the prompt with the context and same image that was working off of. We can see here that at the end of it, we could see that the frequency from 1 to 7, output rises quickly. From 7 to 20, output still increases, but only slightly. Basically, it says that the knee appears at the 6 to 8 frequency, and so it would say you'd cap frequency at less than 10, and you'd probably aim for a reduced frequency somewhere around 6. Okay, that's a good answer. We have it plot the curve, again, does the math here, and plots out this curve, which we can compare from the other data. The analysis, we have it give an equation, which is here. We'll compare those in just a moment. Now this other one, we gave the file with the same prompt. The file is a little bit more precise because it can go straight to analyzing the data. If you look at the code, instead of trying to convert the image, it has the direct data. It goes through its analysis, and it says up to 6 for the frequency, and sees diminishing returns beyond 6. So shows the marginal return. Again, we can have it do a calculation. Interestingly, in this part of the calculation, when I looked over it, and we'll look at that in just a moment, it did not do the calculation the way that I would have liked to. It was looking at the interval frequency instead of the cum frequency. I tell it to plot with the cum and try again, and then we can compare that answer in a moment. I'm going to show you one of the prompt in a minute, but let me go ahead and let's go to the math and see what we did. Now, it's very important, especially when you're first working with data, to be able to plot the curves and look at the data and check the work, especially when you're doing something that you're going to turn into workflow to make sure that it's calculating correctly. Now, this is the actual curve of the data points that were observed in the data, and this is a really good fitted curve. Now, the fitted curve from that simple prompt here, you'll remember that was the calculation is here that we pasted in. We can measure the absolute difference from the actual conversions that we observed, the tickets sold, the cum tickets sold by frequency, and we can measure the error. So it's actually a fairly tight fit to the actual data. This is a good curve. But interestingly, when we compare the data to the advanced prompt on the data, we see a little bit more error. Some of the things that you get with a variation here is a little bit different equation, slightly different in the fit from the data image. When we have the advanced prompt with the data, we actually get a different type of calculation altogether. When we ask it for the file, it gives us this initial image here. I could tell looking at that this wasn't a marginal return because the curve would be nice and smooth. It wouldn't be bouncing around here. So looking at what they did with the calculation, I can see that the real answer should have been to cum the conversions, cum the volume, and then divide cum conversion rate with the cum volume. And that gives you this green curve here. So you can see that the answer it produced is actually off. I went back and said, I see what you did. You should have cummed the conversions. And so it came back and it re-plotted this chart. We can copy this here and see how different it is here. And we can change this chart. You can see that's almost a perfect fit. It's not exactly perfect, though if we were to look really closely, we'd see some small deviations. But this is, again, very close. Part of the reason why I am focused in the yellow and green belt on workflows is because you can be really prescriptive to the AI, and you can reduce the amount of agency the AI has to decide how to fit the curves or make decisions like this. In analysis, this becomes a big deal. Now, we were looking before the difference between some of the best fit curve that we have here, which I'll show in a moment, and the one that came up with the equation is not a whole lot when you plot the chart. And both of them have very low error rates. But the reality is that the error rate is 18% higher depending on how you go about doing the prompt. Now, the most effective prompt is what I call a build-up prompt. I said I would come back to that in a moment. When ChatGPT changed the thinking model, it changed the way that some of the prompts work. The prompt guideline, or the meta prompts that we provided before, where you provided the context, role, objective, approach, output, and so forth, this still is quite effective. And if you are really prescriptive about the output, the type of code that you want to run, it will do that again and again. That can be really powerful. But there's another approach that you can use, which I call the build-up prompt. So in a field of study, in order to move the AI into greater level of expertise, one of the approaches you can do is ask it to explain something that gets it thinking about this space. Now, you saw this when we were looking at lemon water. When we started with the prompt for partial differential equations, this approach I found has been more effective than the rigid prompt, because what it does is it causes the AI to develop its own context that it uses before you give it the next prompt. After we have it go through and give us all of this great math, we gave it the same data and ask it to fit this frequency to impact data. So it's a very short prompt, but because it already has all that expert context, it does a far better job. And as we saw, this one had the lowest error rate and was 18% better than the prompt prior to the thinking models. And the curve fit is, again, exceptional, and this is a good output to use. This is definitely one of the most challenging analysis that we can expect AI to do. It's on the frontier of what AI's capability is. The bivariate dashboard analysis we did earlier by time of day, of course, give that to AI, it should be able to do it. But when we talk about nonlinear relationships and so forth, this is a frontier where I find AI fairly brittle and not always up to the task. Therefore, you should still give it a try so you can see where the edge is of what you can expect AI to do. In this build-up prompt, we say explain diminishing returns in media and the mathematics to calculate it as one way of doing it. This is a type of prompt you should try. It builds up some of the context. Then as it gives the analysis, we give it the data. Here's some data. Analyze the diminishing returns curve, plot the data, and return the equation. I can apply in Excel. In this case, it plots the curve in a way that I would not do. It uses cumulative impressions instead of frequency. But when I ask it, where would I cap the frequency, it does get the right answer of 6 impressions per person, or 8 to 10 if you want to loosen it up. And when I go further to ask it to plot the curve to show why that's the right answer, we see a little bit of this elbow here again. I didn't find this the best analysis, not quite up to the full grade. And when I put it into Excel to check for the accuracy of the equation, its error is again higher than some of the other ones I found. The lowest error I was able to achieve was with a build-up prompt with a more sophisticated calculation, and here the error was a very good fit. And that's probably the best I think you could do. If I were building an AI system that was using this type of data, what I would do is I'd go into this example and I would try it a number of times until I got an answer that was as good as what I thought was possible. I would then copy the code as a few shot example to show it how to do it right. And I would use that same prompt that we were talking before that constrains the output. And I would specify the code that you must use, and I would then specify some error rates that would be acceptable for it to advance. Now, in the diminishing returns example, that requires a high level of precision. If you want to read more about spend impact response functions and how they work, you can either get the book I wrote over a decade ago, or you can probably ask ChatGPT for a summary of it or the key points and key ideas. Definitely encourage you to look into it. It's a really important area. To come back to where AI is at its strengths, when it's doing more like bivariate analysis. You can give it the Prism file that we used for the persona exercise for RAG. You can say, analyze this data and write a report on the characteristics that most define this population, include a succinct persona description. You can see that it has done this type of analysis here off of those 5,000 data points, and it's done a very nice job of summarizing the key differentiators, including the energy drink preference for this population. Now, in Prism and Cycle and Connections, Claritas does not use race or ethnicity, but in that larger 5,000 data points, that was one of the variables. And so it includes that because that was an important defining characteristic of the population. It will be a little bit different than what Claritas publishes in general. But it shows the power to be able to go through these 5,000 data points and give you a really succinct persona of the striving selfies. This is a good use case for AI. We're going to end the video here, but you should be spending probably about a half an hour to an hour playing around this large file to see what you can do, and the other file, which is the diminishing returns curves, either the data or the images. See if you can get a prompt that performs better than the prompt I have here, which is the build-up approach, which ultimately yielded a equation that we see here, and that produced the lowest error rate from my testing today. If you do get one that performs better, I definitely want to hear from you. We will find a nice prize to send you as the winner of this challenge. Also, there's a hidden Easter egg here, which is a small error that we added into the data. See if AI can find that error. It's not a key enough to go through in the white belt training, but we'll come back to it in the yellow belt training. You can test the error rate. The way you can do that calculation is you plug in your fitted equation curve, multiply by the frequency, and it will tell you what its prediction is. You can compare that to the actual, and you can take the absolute value of the difference, and then you sum the absolute value of the difference and see if you can beat 35.27. Good luck.